So starting Monday, we went over investigating exponential functions, and we held up a piece of paper with the scissors, and we looked and we came up with these data points. If we never cut it, how many sheets of paper would we have? And if we made one cut, how many sheets of paper, and so on, okay? And then we came down below and we listed all the ordered pairs, and we recognized what was the first ordered pair and what does it mean within the context of this problem. We also recognized the pattern. To get from one number to the next, we were doubling the y values. Then we took out our calculator and we made a scatter plot with the data points, and we noticed it made a J curve going like this. The points didn't make a straight line. We could connect them to make a line, but not a straight line. All right, so now we're going to go and we're going to make some conjectures. Now, you did already learn this, but there's a great chance some of you may have forgotten. So I'm going to fold my paper in half so it's a little bit easier to see. I'd like you to look down to the very bottom and again have your calculator ready. Please do second plus 712 on your calculator. Second plus 712. We are going to write a function that expresses the values we have from up above. We want a function that models this. And if you have forgot exponentials, they look something like this. When I make a box, we're going to end up putting a number in that place. Now, how can you tell an exponential function? By just looking at the equation. The exponential function will have the variable x in the exponent position. So I want to replace these two with numbers that allows me to model the data that we already created on Monday. How do we do that? Okay. Remember, number of cuts, was that our x or y? That was like our x, or it was our L1 when we plugged it in the calculator. And then likewise, y was the number of sheets, and it was our L2 when we plugged it into the calculator. Okay, so here's what we have. Any ideas what we can do to put numbers in here? Any idea? Any idea? You're not plugging anything in. I just want some ideas. What could go in these places? Do nothing on a calculator right now. Okay, better question is this first value. Does anybody remember what this first value does? When you took notes yesterday, what did this value tell us? It told us, and please do the same in your paper, it told us the y-intercept. And we think of the y-intercept as the initial value. We think of the y-intercept as the initial value. So knowing that, what was our initial y value? It was 1 for this particular problem. Now this all relates to y, the function y. So now this part is known as the rate. It's your constant rate. And with exponentials, your rate is going to be achieved by either multiplying or dividing by the same constant value. So to go from one number to the next, I'm going to have to double the value. And how do we write doubling in terms of numerical value? It is a 2. Let's check to see if this kind of matches up. So just follow my lead here. Go to y equals, and let's plug it in. Now instead of hitting graph, I want to see a table of values. I want to see if they match my table of values. So I'm going to do second graph, and I get my values here. And I'm checking 0, 1. Okay, that's a point. 1, 2 is a point. 2, 4. 3, 8, 4, 16. Okay, it works. And what does it look like on the actual graph? When I hit graph, I can see it's this J curve that we took notes on yesterday. Okay, it's this J curve. It's exponential growth. As you go from left to right, it is rising. All right. So using a calculator to evaluate, you could create for 8 and 9. So there's a couple ways we can get this. So can you please circle 8 and 9? So let's look here and see what would our 8 be. If we had continued, so we can check our answer, if we had continued, bless you, and I doubled 128. What is 128 doubled? 256. And what is 256 doubled? I believe it is 512. Well, let's see if this works. You ready? Please go second trace value. Please go second trace value. In our table, it's asking for the X answer right now. What X answer do we want to evaluate? Remember, X's are the number of cuts. We want to evaluate 8. So plug in 8. We get an answer of 256. Is that exactly what we did by just doubling? Okay, so 8 does go with 256. Now, another way to do 9, instead of doing it this way, I just want to show you an alternative way. Please go second table. Second table, if I do second table, I can go down to 9, and I'm like, oh, there we go, 512. 9 goes with 512. Flip to the back, please. There's a few things I do want to change on the back, but the first one is not going to be altered. Now, what's interesting about this, if you have not been listening to me about the ACT over the course of this year, is that Ms. Geary, who runs lots of analysis of your ACT data, has found that whether you are the top student or you are the low student, consistently our students struggle with integrating essential skills. That means math that's taught below 8th grade. And maybe it's because we just haven't practiced it enough. You know, you learn in 8th grade and then you don't always apply it later on, right? Without a teacher saying, this is how you do something. These two problems are examples of stuff you learned before 8th grade. Now, for time purposes today, I'm going to go a little bit faster, but first period I gave them about 5-6 minutes to see if they could get it. Only one student got number 3, no students got number 4. So I will give you a little bit of time, but not equal to first period. What I want you to do is this. I want you to read number 1, and then as a group of 2 or 3 in the groups you're sitting with, I want you to identify what exactly is the task they want us to figure out. Ready? 30 seconds, go. Okay, here we go. If you have a highlighter already out, feel free to use it. If not, circling also is going to be able to identify. So notebook paper usually stacks up 500 sheets to 1 inch. Okay, is this good information? Possibly. And it says, how thick would the stack of paper be if you were able to make 9 cuts? So I'm going to circle the actual task that it wants me to perform. The task it wants me to perform would be how thick. I want an answer of how thick. How thick? Is your answer going to have units behind it? Yes, it will. What type of units describe how thick something is for this problem? So I know my answer is going to have inches. Okay? Now, it tells me that we want to know how thick when something is 9 cuts. Does it give us any other valuable information? What does it tell us? 500 sheets matches up to 1 inch in height. Now, the mistake a lot of students made last time is, I'm going to write this down really quick. Their automatic thought is, we just learned exponential, so I can only use this equation. How the heck do I do this? In this problem, recall that X represented the number of cuts, Y represented the number of sheets, cuts and sheets. Does this particular problem ask me at this point for the number of cuts and the number of sheets? Does this ask for the number of cuts and the number of sheets? No, it says the number of cuts and not the number of sheets, but the thickness of it. Does this problem right here currently tell me an answer for thickness? No, only for numbers. So that is the differentiation. All right, well, let's take what we know. We know 500 sheets of paper, 500 sheets of paper matches up with 1 inch in height. And I want to know how thick. So the unknown is how thick. So across from this, I could put a question mark. I'm going to put an X for the unknown value. And I want to figure out, okay, 9 cuts. What is 9 cuts in terms of sheets of paper? Well, over here, can 9 cuts, can I use this problem to go 9 cuts and figure out how many sheets of paper? Is this current exponential function set up to tell me the number of cuts and the number of sheets of paper? Is this current? Please flip to the very front of your paper. What is your x value? Number of cuts. What's your y value? Number of sheets of paper. So if I have 9 cuts, can you tell me how many sheets of paper? 512. We just figured it out right in the last problem. You can also plug in 9, take 2 to the 9th, take it times 1, you get 512. Okay, so this is how many sheets of paper. And now, using ratios, which you learned in 7th and 8th grade, you can solve. So how do you solve this? Cross multiplication. 500 times x is 500x. 1 times 512 is 512. Divide by 500. Okay, grab your calculator, please. I want you to practice rounding to the nearest thousandths. As simple as it sounds, every year kids forget how do we round to the hundredths, the thousandths, the tenths. Okay, you ready? You have 10 seconds remaining. Please put an answer rounded to the nearest thousandths. Okay, and it is 1.024. Now the mistake I made is, does everybody see these little approximately? Approximately means you rounded. Do we have to round? And as a quick review, after the decimal moving to the right, this is your tenth, your hundredth, and your thousandth. This is an exact answer. There's no rounding, so I could just put equal. So if you were asked how thick would your stack of papers be if you were able to make 9 cuts? Okay? How can we answer that with a complete thought? You have 30 seconds to think. You're going to have to share it with somebody else. If you received bonus points for having the most thought to your answer, if I was going to say it, you're going to get extra credit if you can be as concise as possible and include as much information as needed. What would your answer be? Whoever's sitting in the middle seat, please share with the rest of your group. You have 15 seconds, right or wrong. Do your best, go. Dan, you're in the middle. Here would be an example. It doesn't have to be exactly like mine, but it could be something like this. Cutting 9 sheets of paper creates 500 and, let me go back here. Creating 9 cuts creates 500 sheets of paper, which would be 1.024 inches in height. Making 9 cuts creates 512 sheets of paper, which would be 1.042 inches high. I'd like you to create a complete sentence on your paper right now. You are going to alter number 4. Please change this on your paper. So the very beginning is the same. Suppose each cut takes 5 seconds. If you had been able to keep cutting, you would have made 36 cuts in 3 minutes. That is all currently on your paper. Now here's the new part. I'd like you to cross out anything after that point and write this question. Here we go. Working consistently at this pace. Working consistently at this pace, how long would it take you to cut 500 sheets of paper? Working consistently at this pace, how long would it take you to cut 500 sheets of paper? So what is the question? How long? I want to know how long. That's my question. How long? And what is that going to be in terms of? Well, it's in terms of time. Could be in terms of seconds. Maybe we'll do it in terms of minutes. Let's write down what we know. We know that 1 cut takes 5 seconds. And we want to know how long again. So put my little x value over here. How many cuts are we going to make this time? We have 500 sheets of paper we're going to cut. So 500 sheets of paper is going to be cut. So it's going to be 500 cuts please go ahead and solve right now. You should come up into an answer of 2,500. Remember, this is in terms of time and in terms of seconds. Now, there's nothing wrong with that answer, but let's put it into, like, when somebody says 2,500 seconds, you're like, okay, but what does that really mean? So let's go seconds to minutes. Let's divide that by 60. It'll make a little more sense to us. This tells us if we have 500 pieces of paper, we're going to cut each piece of paper one time. Remember, working at a constant pace of 5 seconds per cut. It would take us approximately 42 minutes. It would take us approximately 42 minutes to take each of the 500 sheets of paper and cut them each one time. Okay, writing a complete sentence right now for number 4. Your last one is number 5. Please cross out what you currently have for number 5. Instead, if I tell you that you're going to make 22 cuts, and I want to know how many sheets of paper, you need to explain to me 3 different ways that you could come up with that answer. 3 unique ways you could come up with the number of sheets of paper after completing 22 cuts. 3 unique ways. When you are done, you bring it up to me.